A cameraman standing at A is following the movement of a race car B, which is traveling around the curved track at a constant speed of 30 meters per second. Determine the angular rate theta dot at which the man must turn in order to keep the camera directed on the car at the instant theta equals 30 degrees. And here comes the hint that we just mentioned. Theta dot is required, which is part of v theta, and v theta is part of the magnitude of the velocity. So to find v theta, so we can solve for theta dot, we need the magnitude of the velocity, which is given by the way, and we need vr, which is r dot. And to do that, we have to find r first, which can be found from this triangle. So as you can see, 20 and 20 means that this is theta and this is also theta. And if we take the normal, it will split this line into two equal values. 20 cosine the angle and also 20 cosine the angle here. And if we add them up, you will get the value of r, which is 40 cosine theta. And if we derive r with respect to time, we'll find r dot, which is minus 40 sine theta, theta dot. Again, this is dr over d theta multiplied by d theta over dt, which is theta dot. So we got r dot, we have r, we have v, our only unknown is theta dot. So by applying, you can notice here that minus 40 square and 40 square also will be a common factor, in addition to theta dot square. So we can take both of them as a common factor, and the remaining in the bracket will be sine square theta plus cosine square theta, which is going to be equal to 1. And the result now is theta dot equals 30 over 40, which is 0.75 radians per second.